Okay, so still continuing on with the quadratic formula, you guys. So if you look at these, and it's the same thing, we're finding the exact solutions, the approximate solutions, and we're checking with the calculator. Okay? So if you look at all of these on this page, they all have some manipulation that you have to do to get them in standard form to be able to substitute into the quadratic formula. So this one, you need to distribute, get everything on one side of the equals. So why don't you guys do that, and I'll do it, and we'll see if we get the same thing. Let's see. So this is what I end up getting. Okay, so A is 1. I hope I have enough room. B is -6. C is 9. You could almost solve that one in your head without the quadratic formula, but here we go. So x equals -b, or the opposite of b, will be 6. Plus or minus the square root of oh, I see why this one is on here. All over 2a. So it's 6 plus or minus, this is 36 minus 36. Okay, that gives you minus 36. This is 36. If you're putting that in the calculator, you need the parentheses. So you get 6 plus or minus root 0 all over 2. So 6 plus or minus 0 over 2. So think about this. That's a plus or minus there, you guys. And I got a little sloppy here. So 6 plus 0 and 6 minus 0 are the same thing. They're both 6. So I still will show you, though. So you get 3 over 2, 3 over 2. Ah, sorry, 6 over 2, which is 3. I knew something wasn't right there. And 6 over 2, which is 3. So this guy only has one solution. And remember, we did talk about this, what that looks like. So shall we look on the calculator? Minus 6x. Okay, so here's that one. So it only touches the x-axis in one place, and that place is actually called the vertex. It's the lowest point in this case. So it only hits it in one spot, and it bounces off the x-axis there. Okay, so we're verified. And that's what happens when there's only one solution. It bounces off the x-axis at that spot. Okay, so next one. This one's all set up. The numbers are a little funky. Okay, notice I already wrote the quadratic formula for you. You should be writing it over and over so you can commit it to memory. So -28 plus or minus 28 squared minus 4 times -49 times -4. These numbers look a little big. All over 2a. So 2 times -49. Okay, so here we go for the calculator. So, just to show you, you can do this all in one step in the calculator. That's everything that was under the radical. Okay, and you get 0. All over -98. So you're going to end up getting -28 plus or minus the square root of 0 over -98. So it's -28 plus or minus 0 over -98, which ends up just being -28 plus 0 is the same thing. I'll write it down. Let me put this here. Negative 28 plus 0 is the same thing as negative 28 minus 0. It's just negative 28. Let's see. I would like that simplified. Two sevenths. So this is another one with just one solution. So how's it going to look? It's going to bounce off the x-axis, but let's look. Okay, so there it is. Everything good. It should bounce at 2 sevenths. There it is. And see, notice this one, it opened downward. So that point is called the vertex, and it's the highest point in this case. Okay? That's 2 sevenths on the x-axis. All right, next couple. 2x squared plus 8x plus 17. I combined a couple steps there. A equals 2, B equals 8, C equals 17. X equals negative B plus or minus or the opposite of B. 8 squared minus 4 times 2 times 17. All over 2 times 2. Okay, so you can do everything under the radical, all in one step in the calculator. You get negative 72. Okay, so here's an interesting idea, y'all. A negative number under the radical. It's over 4. Okay, so let's backtrack. So negative number under the radical, what does that mean? There's going to be an I in your answer. So remember, you have to simplify this guy. So you're going to break it up into negative 1 times root 72. So root negative 1 times root 72. And root 72 can be broken up into 36 times 2. If you're looking for the biggest perfect square in there, okay, so this is I, this is 6, and that will remain radical 2. So look at what that looks like when I write it over here. Negative 8 plus or minus 6i root 2, all over 4. Okay. You can break this up into this over this and this over this, because you can see there's some common factors in here. Okay, so that simplifies down to negative 2, and this you can simplify it into 3 over 2. So look at how I'm writing that. Okay, so what's going to happen when we go to graph this thing? Okay, these solutions have i's in them. So let's see. Okay, so there it is. I think probably some of you have an idea what's going to happen with the graph. If the answers have i's in them, you could see it's all up there. And if I change the window, let me just increase the y max to maybe 30. Okay. It does not cross the x-axis, and that's the way it should be. When you solve and the solutions are complex, if they have i's in them, that means it does not cross the x-axis. And vice versa. If you know a parabola does not cross the x-axis, when you try to solve it, you will get non-real solutions. All right, last one, straight up formula. So what you're going to do here is you need to clear out all the fractions first. So you're going to multiply through by the least common multiple of the denominators, which is x squared. Okay, every single thing has to get multiplied by x squared. So this is going to be 4x squared. When you do 3 over x times x squared, you'll get 3x squared over x, which is 3x. And on the right side, those will cancel each other out, and you have 5. Okay, so you have to clear out all the fractions. Move over 5. Decide what A, B, and C are. Okay, x equals the opposite of b, so 3 plus or minus the square root of all over 2a. This is 9. This is 80. So plus 80 all over 8. That's just a 3. Okay, so you cannot simplify that. 89 doesn't have many factors, if any, other than 1, and I can't think of any perfect squares that go into 89. So this is simplified the way it's sitting here because root 89 is not simplifiable because there's no perfect squares that are factors. So now you're going to go into the decimal estimates. So one of them will be gotten by doing that problem. The other one will come from doing this problem. Okay, so all in one line in the calculator, please. So there it is, round to 2 places. Look what I did here, 1.55. And then the same one with a minus in there. There it is. Negative 0.8. Okay, I'm not going to graph this one on the calculator, but I want you to. Here's your exact solutions. Here's your decimal estimates. These are not classified as exact solutions because they're rounded. If you graph the parabola, so if you go back and you graph this guy, it'll cross the x-axis between 1 and 2 and between 0 and negative 1.